Hello everyone, today I'll be recording a pure math YouTube video and we'll be starting with truth tables. So now that I did most of trigonometry, I'll be going into module 1. So we're going to go through module 1 again and just try to go through everything as slow and understanding as possible. So let's start. So in truth tables we deal with these things called prepositions. Now you might not know what this is, but it's simply a statement that can be true or false but not both at the same time. So what do I mean? So we know there's 7 days of the week. There's Sunday, Monday, Tuesday, Wednesday, Thursday, and Friday, and Saturday. I almost forgot. So 1, 2, 3, 4, 5, 6, 7. So if, for example, I said today was Wednesday, so Wednesday would be right here. But if today is Wednesday, then that statement would be true. However, if I said that same statement, today is Wednesday, on a Sunday, well, that statement will not be true because on Sunday it's not Wednesday. So this statement can be false and it can also be true when it's on Wednesday. And so we can say this is a preposition because it can be false and it can be true, but it can't be both at the same time. Okay, now how would we denote this? So if today is Wednesday, we'd say if it is Wednesday today, we can denote this by being true by having a 1 or having a t. So 1 or t refers to if today is Wednesday or not. So as you see here in the notation section, it can be denoted by t or 1. So that's how we tell if today is Wednesday or not. And if we want to see if today is not Wednesday, we can have a false or 0. Either of these work. For the purpose of these videos, we're going to probably mainly use numbers, but you can use T or F, it doesn't really matter, but it's very intuitive. True for T for true and F for false. 1 for true and 0 for false. Just very simple things that you guys should know. And now we're moving on to simple statements. Now, what is a simple statement? So the definition here is that a simple statement cannot be decomposed into separate statements. So what this means is, for example, if we have here, the cat is big and the dog is red. Now, this statement can be decomposed into two different statements because we can have the cat is big as one whole sentence and we can have the dog is red as another sentence. So this is not a simple statement. So instead, something like the sky is blue, well, there's no conjunction, there's nothing that's suggesting it should be more than one sentence. It's just one sentence. Without everything in the sentence, it wouldn't be a sentence. So, well, that sounds kind of confusing. But yeah, this sentence, the sky is blue, cannot be separated, can't be broken down. Not like how the cat is big and the dog is red. So that is what a simple statement is. Now, you probably won't be asked to list a definition or anything like that. It's just something that's nice to know. So let's continue. So now we are getting into actual truth table things. So now we're going through negation. So what is negation? So for example, we say let P, which is just a variable that we use. So we say P is a proposition, and we can say P is equal to, for example, you can use the simple statement the sky is blue. Now the negation of P, which can be denoted as like a squiggly line, this is read as not P. So it's read as the negation of P. So if we had, so using numbers, if we had P equals 5, then the negation of P would be equal to -5. So it's just a negative version of P. So if P in this case here, if P here is the sky is blue, then the negative version of the sky is blue is the sky is not blue. And yeah, and what can we do with this now? So we know P is equal to the sky is blue, and we know the negation of P is going to be equal to the sky is not blue. So that means that when the sky is blue, we can put 1, or for for learning purposes, I'll just put T. So when the sky is blue with this P preposition, then that means that for the statement the sky is not blue, this would be untrue. So we'd have to put 0 or false. Because when the sky is blue, then the statement "the sky is not blue" will not be correct. Okay, so let's continue. It's the opposite value. So the preposition P will always have the opposite value of its not value, which is not P. Okay, so if P is 1, then not P is going to be 0. So let's go. So we're going to practice a little bit. Negate the following prepositions. So we'll let this be equal to P. So we'll say the dog is blue is P. And let's say if the dog is blue, then we'd put 1. And if we're not P, if the dog is blue in 1, so that means that the not P value, this one over here, has to be the opposite of the P value. So we put 0. Okay? And if it is that the door is open, so we could let this be equal to Q. The negation of the door is open is the door is not open, or denoted by not Q. So that means if Q has a value of T, then not Q is going to be the opposite of T, which is false. And if Q had a value of false, then not Q is going to have a value of true, because they're just opposites. So it's not going to be the same, it's going to be the opposite of whatever the first one is. Okay, moving on. Truth tables. So we actually have a way that we write truth tables, and this is that exact way. So we write truth tables in a table, as you could have guessed. My text to shape is not working, so I'll just kind of draw this by hand. Okay, so if we have P and we have not P, what we do is for the amount of prepositions we have, which in this case we just have one preposition, because this is just something we can do to that same preposition, but it's not actually a different preposition. So with that one preposition, this one statement, we have 1 and 0, okay? And when it's not P, we can just negate that. So you get the negating part. But how do we know how many of these 1s and 0s we should use? So it's simple. The amount of rows that a truth table has is equal to 2 to the number of n. And what is n? N is a number, where n is a number of propositions. So if it is that we had P and Q, then we would have 2 to the power of 2 prepositions, which means that would have 4 rows. Okay, but in this situation, since we only have P, which is the only preposition, we just have 2 to the power of 1, which is equal to 2, hence why we have 2 rows. Hopefully you're understanding so far. Okay, compound statements. So I kind of spoke about this a little bit earlier when we were talking about simple statements, but nevertheless we'll go through it the same. So two simple statements joined together is what a compound statement is. So in this example, we still have the cat is blue and the dog is yellow. Now these two statements are connected by and. So the cat is blue is a simple statement and the dog is yellow is its own simple statement. But when they're connected together by the and, they form a compound statement. And now we're going to be going into connectives. So this is another part of truth tables. Now we're getting into actual parts of truth tables where you'll more than likely be tested. So conjunction, or in this case and, we call it and, right? And anything that's joining the two sentences, we use and. It's denoted by this. Now I'm going to try to draw it better, but yeah, it's essentially denoted by this. So if we were to say P and the Q, what we would really be doing using the notation, it would actually be P and Q. Okay, and so let's try this now. So first of all, let's look at how many propositions we have. So we have P and Q, which means these two could be any kind of propositions. We're just using their value here. We're just using their variable. They could be anything. We don't need to know what they are right now, or at all actually. So if we have P and we have Q, that means we have two propositions, right? So that means the number of rows we'd have is 2 to the power of n, where n is equal to 2. So we'd have 2 to the 2, which is equal to 4. That's why we have 4 rows here. And this is how we fill out our rows. We fill out our rows with 1, 1, 0, 0. So we fill it out with 2 trues, 2 false. And then the next one, we'll go 1, 0, 1, 0. So this time we alternate. And let's say you had 3, there is a third proposition here. What you would end up having is 1, 1, 1, 1. You'd have it 4 times. You'd have 4 ones, and yeah, but you'll get the hang of that in time. But right now what we want to do is just solve this truth table. So in this situation we have P and Q. Okay? So what does this mean? So for P and Q, if we want the P and Q, the statement will only be true if both P and Q are true. Okay? So in this statement we have the cat is blue and the dog is yellow. So in joining those two we'd need both of those to be true. Okay? So we'd have 1 here. But if we have the cat is blue, and since Q is 0, that means that the dog is not yellow, right? So if the cat is blue and the dog is not yellow, well, that's not what the statement we have up here is. That's a different statement, so that's not true. And the same could be said for if the cat is not blue and the dog is yellow. So these other ones will not be true because they're not going to make the proposition up here true. The proposition is that the cat is blue and the dog is yellow. That is a true statement. So we need both of those to be true. And if they're both not true, then it's not correct. So we can't say that. So every other truth value would be 0. Great. Now we're going to be moving on into disjunction. Now this is just or. So we'll say, for example, we have 2 dogs. I just call them Sally and Ron. And we say Sally is blue or Ron is red. So what does this mean? So first let's fill out our truth table before we even get to that. So we have P and we have Q. So since we have 1, 1, 0, 0 in the P section, that means that for the Q section we know we have to alternate 1, 0, 1, 0. Okay, and for P or Q, well, we need at least one of these to be true, because if this is true, then the whole statement is true, and if this is true, then the whole statement is true. So in that case, this should be true because the Sally is blue or Ron is red. That's true. Sally could be blue or Ron could be red. And again, if we had Sally is blue in this section or Ron is not red, well, Sally is blue, so that works, right? So that could be true. Put 1 for true. And if Sally is not blue but Ron is red, well, we still have one of them being true, so that's still true. But for when Sally is not blue and Ron is not red, this does not match any of the conditions set here. The prompt, or well, not the prompt, but the propositions state that Sally is blue or Ron is red. And if Sally is not blue and Ron is not red, then this is just not true. So we have to put false or 0. But I'll just put false here. But for future reference, you probably shouldn't mix 1s and F's. Just use one thing. So if you're using 1, you're using F. And just again, this is the disjunction sign. It's like a V. So it's like PVQ. Okay. And now we're going into De Morgan's law. So what is De Morgan's law? So let's say you had a negative sign. So let's say you had negative 5 plus 3. I'll use variables. Negative 5x plus 4. So since this is in a bracket and the negative sign is outside the bracket, the negative sign can be distributed to each thing in the bracket. So when distributed, this would be equal to minus 5x minus 4. So because the negative distributes over here, this middle sign changes and it goes to minus. So this is actually just the same thing for De Morgan's law. If we had 2 propositions and we said P and Q, well, if we negated this whole statement, and this time we're not negating P and we're not negating Q alone, well, this could be expanded as equal to the negation of P. And since we're negating it, this is going to be distributing towards everything. Since we're negating it, what we are going to want is we're going to want to change the sign. So we're going to flip the middle sign, and it's going to become VQ. Or sorry, negation of Q. Okay, so we just flip the sign, and that's essentially what we do. And so the same thing, let's say if we had the negation of P or Q, well, expanding this, distributing the negative sign, or well, the negation sign as I like to call it, I just think of it as a negative because it's more intuitive for me. We can just say, okay, negation of P, and because we're flipping this sign, negation of Q. Okay, and that's simply just De Morgan's law. It's kind of intuitive once you know any sort of algebra, and yeah, hopefully it's making sense right now. And so now we're going to be moving into conditional statements. So a conditional statement is denoted by this. It looks like a little arrow, which means then. So let's see. If we have something that says if it is night, then the sun is out, then this is a condition. So the only time it is night is when the sun is out. Okay? So if it is night, then the sun is out. Well, this doesn't really sound like it makes sense, but I'm just using it as an example, okay? So if it is night, then the sun is out. So it is only if it is night, it's only then that the sun is out. Okay? So the condition for the sun being out is for it to be night. So for example, if it is night, if it is night is true, then the sun is out will be true. Okay, so let us move to the truth table. So again, what we want to try is we're going to want to try to fill in this truth table. So now we're looking at this and we see that there are two propositions, okay? So we know to fill out this by doing T, T, F, F. And for Q, since it's the second column, we have 1, 0, sorry, T, F, T, F. So P then Q. Now let's try to reason this out for this one. If P then Q. So if it is night, then the sun is out, right? So let's try this. So if P is true right here, so if it is night, then the sun is out. That's true because that's our whole statement. But let's check this now. If it is not night, if it is night, sorry, it's the same for this one over here for the second row. If it is night, then the sun is not out. Well, this is not what we said. We never said that the sun would not be out. So that has to be false. So this is going to be false. So I just remove the X so you can see that when it's CF, this is going to be false. And let's move on to the third row now. So if it is not night, then the sun is out. Well, let's think about this. If it is not night, then the sun is out. Well, we never said that the sun had to be out only when it is night. We just said if it is night, then the sun is definitely out. So this statement can also be true. And now in the last statement, if it is not night, then the sun is not out. Well, that's true. If it's not night, then the sun is not out. This could be true. And so this is what we have to think about when we're doing this, right? Okay. Great. Now we're moving on to the contrapositive. So these are just some things that you might need to know. Okay, so the contrapositive is just if we had two prepositions and we had P, then Q, the contrapositive is just you flip these around, so you flip the order of them. So you flip this, the order of them, so then you have Q, then P, and then you negate them. So then you negate Q and you negate P. And that's just a contrapositive. You flip the sign and then you flip the position that they're in. Okay? And then now we're going on to converse. These are just some things that you need to know. They're very small things. Just hopefully you understand what contrapositive is. You just flip the sign and flip their order. And then that's all there is. And the converse is just very similar to the contrapositive, except for this you don't flip the sign. So if you had P, then Q, then the contrapositive of this is, sorry, the converse of this is just flipping the order. So then we'd have Q, then P. Right? We just flip the order, and if we were to do the contrapositive, we would negate both sides. But we're not doing that right now. This is just a converse. And now let's go to the inverse. Okay, so if we had P, then Q, and we wanted to find the inverse of this, we would just negate both sides. So we'd say the negation of P, then the negation of Q. Okay? And yeah, that's all the inverse. Inverse, you just change the signs. The converse, you just change the position. And the contrapositive, you change both sign and position. So these are just three things you can learn. They're very easy to learn, and you will be tested on them. So I'd recommend just trying to memorize them, and we will move on. So now what we need to talk about is truth table equivalence. So what do I mean by truth table equivalence? Well, we haven't done much with truth tables yet, right? So what do I mean by equivalence? Well, truth table equivalence is just when two truth tables have the same truth values. And I'll explain what I mean soon. Don't worry about that. So let's say we want to find if something is logically equivalent to another. Well, we're just trying to say if it is that this statement, this propositional statement, has the same truth values to this one, then we'll classify that as logically equivalent. Okay? Because yeah, if they have the same truth values, they're logically equivalent. So let's try it out. Wow, so this is going to be the biggest truth table you've seen so far, if you've just been watching this video. So this is a lot to fill out. So let's try to fill it out slowly. So we see there are two propositions P and Q. And everything else on this side, we don't have to worry about that as much because these aren't exactly propositions, these are just things that we're doing to the proposition, okay? So for example, here we have P and Q. So since there are two propositions, there are 4 rows, and we know how to order this now. We have 1, 1, 0, 0, 1, 0, 1, 0. So now when we're talking about the negation of P, we're in this column now. If we want to negate P, well, simply we just have to find whatever value of P and use the opposite of it. So in this case, P's value is 1, so the negation of P is going to be equal to 0. In the second row, P's value is also 1, so the negation of P is going to be equal to 0. Now in the third column, P's value is 0, so when we're negating 0, we'd get 1, because 1 is going to be the opposite of 0, as the same way false is the opposite of true. Okay? And when P is 0 again, we have 1 again. And now we want to find the negation of Q, or we want to find not Q. So if Q over here is equal to 1, then in the not Q section we'd have 0. And when Q is equal to 0, then not Q would be equal to 1. If you get what I'm saying, we're just flipping it and just try not to get lost, because sometimes you might accidentally click the wrong column that you're using, and yeah, you don't want to mess that up. So let's just keep going. So let's say you have negation of P or Q, because this little V sign is or. So we're going to look for the negation of P, and we're going to look for Q, just normal Q, not Q, we're just looking for negation of P or Q. So if we look for the negation of P, we see 0, 0, 1, 1, right? And if we look for Q, we see 1, 0, 1, 0, because Q is right here. Right. So moving on, so a negation of P or Q. So we know this is only going to be true when either one of them is true. So let's look through this. So we have the negation of P is 0 in the first row, and Q is going to be 1 in the first row. So since Q is true, then this will be true. It's going to be 1 because at least one of them is true. Because that's how disjunction works, right? So if we look in the second row now, if we look in the second row, we have 0 and 0. Because we're looking at the negation of P and we're looking at the negation of Q. So when they're both 0, this is going to be false because we need at least one of the statements to be true. And so for the third one now, we're looking at negation. We're looking at 1 and 1, which is going to be true because at least one of them is true, so that's fine. And in the last column, we have 0 and 1, and because at least one of them is true, everything will be true. And so that's that. So this is how we fill out our truth table. We're just comparing the values, and that's essentially all you need to do for the rest of this. So I wanted to try to fill out the rest of this truth table and just pause the video, fill it out, and then see what you did and if you did it right. Okay, moving on, we have P now, and we have P and the negation of Q. So remember this sign right here, this one is and. Okay, so we're looking for P, so we see P here, and we want the negation of Q. So we're looking at these two columns. So this one and this one. So for AND gate now, well, not gate, this is technically logic gates still, but for the AND gate, what we want is we want both to be true. So in P, so we look at P is equal to 1 in the first row. I'll just order the rows so that we can actually see them: first, second, third, fourth. So if we look in the first row, we have 1 right here. And if we look in the not Q's first row, we have 0. Now, because we need both of these to be true, this can't be true, so this has to be false. So we denote this as 0. Now, if it is that we're in the second row now, we're looking at the second row right here, P is equal to 1, and negation of Q is also equal to 1, so both of them are equal to 1. So that means this is going to be true, because for the AND gate, both values have to be true for the whole statement to be true. Now in the third section, we have 0 and 0, so that's false. And in the fourth section, we have 0 and 1, so that's also false. And now, we're going to be looking at the negation of P and Q. So what is this? So we have P and Q over here. We're just taking the negation of that. So whatever value we had here, in this next column, we're just going to negate it. So we're going to, so instead of 0 for the first row, we're going to have 1. And we're just going to be negating this one. So the opposite of 1 is 0. The opposite of 0 is 1. And the opposite of 0, again, is 1. And now they asked us if the negation of P or Q is equivalent to the negation of P and negation of Q. So what we're looking at right now, we're trying to look at two tables. We're trying to look at these two. I'll just put in a different color so we can kind of see. So we're looking for negation of P or Q, which is over here. I hope you're seeing it. This is what we're looking for. We're looking at this one. And we're also looking at negation of P and negation of Q. So we're looking at this last column. So what do we want from this last column and this first column? We want to say that the truth values are even. So if they're equal, then that means that they're logically equivalent. So let's look at this. In the first row of P, negation of P or Q, we have 1, and that matches the first row of negation of P and negation of Q. And if we just keep comparing each of these rows, we have false and 0, same thing, 1 and 1, and then we have 1 and 1 at the bottom. So since, and you're going to want to say this, right? Since both have the same truth values, they're logically equivalent. Now, I would recommend actually writing out which propositions you're talking about. So instead of saying both, you would write since negation of P or Q is, and negation of P or Q as well as negation of P and negation of Q have the same truth values. They are logically equivalent. And you have to write it out, you don't have to write it out in word form, you just write it out in the notation like we have it in the table. And yeah, so this got a little messy kind of fast, but hopefully you're getting it. Now, here's where we're going to start going to something else. We're just going to go through these three things, just like very easy things to remember. So a tautology is when all truth values are true. So if we had, for example, let's see, P, Q, negation of P, negation of Q. So that's 1, 1, 0, 0, 1, 0, 1, 0. So negation of P is going to be 0, 0, 1, 1. Negation of Q is going to be 0, 1, 0, 1. And now, let's see, if we did, okay, so I'm not okay. Right. So if it is that we look at these two columns, right? If we use an OR gate, think about it. If we use an OR gate, if we said P or negation of P, this means that we just need one of them to be true. And in the first row, we have 1, and this is 0. So this whole statement is going to be true because at least one of them is true. And if you go through each row, you realize that every single one of these, like there's always a time when one of them is true, not both, but one. And since all of these truth table values are true, or truth values are true, we call this a tautology. Okay, so a tautology is when the truth values are all true. Now, a contingency is when neither all true nor all false. So a contingency is just like everything we've been working with so far. I mean, if you were to do, for example, P using the prepositions from down here, if we were to do P and not Q, well, if we look at the first row, we're going to have 0, 1, 0, 0. So this is not all false, but it's also not all true because we have false here and we also have true here. So this is different. So we're going to call this a contingency, where it's neither all true nor all false. Now, what if, for example, we had P, and instead of having it or this time, what if we had P and the negation of Q? Negation of P, sorry. P and negation of P. So in this case, wherever P is true, negation of P will be false, right? So we know both of them will never be true at the same time. So this means that they will always be false. And so this is what we call a contradiction, because it's always false. And that's basically all you need to know for truth tables, right? So we're going to move on into some past papers, but truth tables is a very easy topic. It's probably sorry, not probably, it is the easiest topic in all of pure math. And yeah, we're going to move on to some past paper questions. So hopefully you're following. If you're not, try using your textbook and just going over it, and hopefully it will get more clear eventually. I know this might look like madness if you're not following, but yeah. So we're going to start with June of 2022. So let me just change my pen to a black pen. So for June 2022, the question says, let P and Q be any two propositions. Complete the truth table below. Okay, let me just have a sip of water. Okay, so we get 3 marks for just filling out this truth table. Seems easy enough. So they give us P and they give us Q, and they want us to negate Q in this first section. So if we see Q's here, we just want to find the opposite of whatever Q is in. So in the first row, we have true, so it's going to be false, true, false, true. We don't know, we're literally just picking the opposite of whatever is in this row because they're asking us for the negation of Q. And now, they want us to give the negation of Q and the P. Remember, this is a sign is and. So for negation of Q and P, we're looking at the negation of Q column, this one right here, and we're looking at the P column, and we want both of them to be true at the same time for this to be true. So in the first column, we have T and we have F, so that's going to be false. In the second column, we have T and we have T, so that's going to be true because for an AND gate, we need both values to be true for the whole statement to be true. And for the third value, we have false and false, so that's not true. And for the fourth value, we have false and true, which is also false. Okay, so we're getting our marks really easily. I'm guessing you get 1 mark per for filling out each of these columns, which is really easy. So let's continue. So in this last column now, they have us have P or negation of Q and P. So they're asking us to do P or a whole other group of propositions. So you don't have to worry about doing this individually since you already found negation of Q and P. You just have to find the truth tables that you use from here and the p-values, and you just need to know how an OR gate works. An OR gate works as long as one is true, all are true. Okay? So let's go. So we just need one of them to be true. So for the first column, for the first row, sorry, right here and right here, we have TF, this is going to be true. Second one, we have TT, this is going to be true because at least one of them is true. For the third column though, we're going to have F and the F, which in this case, that's we don't want that, that's false. Because an OR gate needs at least one to be true. And for the fourth column, we have F and F again, which is also going to be false because we need at least one to be true. And yeah, so that's what we have. So we just got our 3 marks like that very easily. And now they're saying, hence, state whether the statements negation of Q and P and negation of, P or negation of Q and P are logically equivalent. So what do we do now? We look at the column. So this is, let me just erase it so you can kind of see. Oh, sorry, not that far, but yeah. Because it's kind of messy. So now we can see them clearly. and we're looking at these two columns. They want us to tell if these two are logically equivalent. So we look at this. So do these two have the same truth values? Well, in the first column, this has false, and in the first column, this has true, right? So that means that they don't have the same truth values. Even though the rest of things may fit together, the first one doesn't. So they are not logically equivalent because, please don't write equiv. I'm just using this shorthand because it's a YouTube video. Because they don't have the same truth values. Okay, and that's all it is. And you just got 5 marks on your peer math exam. 5 out of That's 5 marks out of 150. For your sake, I hope you get a lot more than that. But yeah, I mean that's free 5 marks, so you don't have to do anything for that. You just have to know this very basic stuff, and it's pretty easy. So again, they're asking us another time to fill out these truth tables, and this is for June of 2021. So again, the question says that P and Q be any two propositions. Complete the truth table below. So they give us negation of P. If whatever we have in P, we're just going to find the opposite. So false, false, true, true. Because I've been saying this so much now, I'm going to kind of be speeding through it. Because I've been repeating it a lot, so hopefully you're kind of getting it by now. A negation of Q, the opposite of Q, not Q, is going to be false, true, false, true. And the hardest part about this is just finding where Q is, to be honest. After that, you just know exactly what to do. And now they're asking us to find P or Q. Remember, or is this little V sign, and is that like upward sign? I don't know what it's called. So just remember those two. So P or Q. So we're looking at P and we're looking at Q, and we just need at least one of them to be true. So in the first column, that's going to be true, 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 false for the last one, because neither of them are true. And for the OR gate, we need at least one to be true. And now for the negation of P or Q, remember, don't get frightened or startled and just start to use De Morgan's law and flip it, because I know some people might start using De Morgan's law. No, you just did P or Q in this last column, so you just have to negate whatever you had there. Okay, so it's going to be false, 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 true. And now in this last column, we're going to have negation of P or negation of Q. Now, if you realize something, I'm just going to draw it out a little bit. If you remember from De Morgan's law, what I was saying earlier, if you have negation of P or Q, if you expand it and distribute the negation sign, you have negation of P and negation of Q. So that would be what De Morgan's law is. So don't get confused, because remember, you have to change this middle sign, right? You can't keep it the same. And so I think they're trying to trick people by leaving the middle sign the same, and they might think that it's De Morgan's law, but it's not De Morgan's law. So let's continue. So negation of P. So we look for the negation of P column, which is just over here, or negation of Q. So we just need at least one of them to be true. So in the first column, neither of them is true, so that's false. In the second column, negation of Q is, second row, sorry, negation of true, negation of Q is true, so that's true. In the third one, negation of P is true, so that's true. And in the fourth row, both of them are true, so that's also true. Because for the OR gate, we just need one to be true, one of the two. And now they're asking us, hence, state whether the statements negation of P or Q and negation of P or negation of Q are logically equivalent. So we look at this negation of P or Q. We have FFT, FFFT, and in the other one we have FTTT, FTTT. Yeah. So instead, this is not. They are not. Are not. You know, because different truth values. Okay. So they're not because they have different truth values, and then that's just all they're asking for, and that's 6 marks that you're getting. So that's pretty good. So let's move on. We're going now to 2018. So this is the past paper 2018. This is question 1A. Wow, these questions are so similar, which is just showing if you really get truth tables, then you have nothing to worry about because it's the same thing every time. And it was my year as well, by the way, because I also did pure math this year in 2023, and of course I came back with my distinction, so I'm very happy with that. And hopefully, after watching all these videos, you will have a distinction as well. So let's continue. Let P and Q be two propositions. So again, negation of P, this should become second nature to you by now. Negation of Q, 0, 1, 0, 1. P or Q, we're looking at P and Q, just need at least one to be true. These two columns over here, so we're looking for at least one to be true. Both of them are true in this column, this column, this column, and both of them are false in this column, so it's going to be false. And now they want us to get the negation of P or Q, so we're just taking this and negating it. So whatever value we have in this negation of P or Q section, we're going to just negate it and put it in this here. So it's going to be 0, 0, 0, 1. And now they want us to find negation of P and negation of Q. So if you remember what I was talking about again, so we have negation of P or Q in brackets. When it's in brackets, it's different. And then we distribute the negation sign. We'll have negation of P, flip the middle sign to be and negation of Q. So essentially, without even really working this out, we know that these two have to be the same. They have to have the same truth values, right? So negation of P and negation of Q have to have the same truth values of negation of P or Q. And that would kind of mean that they're logically equivalent, but we don't even have to know that yet. So let's just try this out. So let's look at the columns negation of P and negation of Q. So we need both of them to be true for this to be true. So in the first column, in the first row, I keep saying columns, we have both being false, so that's false. In the second one, we have only one being true. Third one is the same, only one being true. And in the fourth one, both of them are true, which means that it's true because for the AND gate, we need two truths to satisfy it. So let's look. Even without looking at the second part of the question, we know that these had to be logically equivalent because it's just expanding. It's like saying, it's the same thing as saying 2 times 3x plus 5 is equal to 6x plus 10. Because these two things are the same. One's just factor and one's not. And that's the same thing we're doing here. So they're the same thing. And so now we're looking at the next question. This is hence state whether these two are logically equivalent, and they are. Because same truth values. Great. And now we're moving on to June 2015 for the rest of region. Okay, great. Let me just take a little sip of water again because I've been talking for quite some time. Okay. So let P and Q be any two propositions. State the inverse and contrapositive of the statement P then Q. Okay. So do you guys remember what I was talking about with inverse and contrapositive? Maybe you don't, maybe you do. But they're asking us to state the inverse and the contrapositive. So I'll just put I'm going this way and go this way. So we have P then Q. Remember, this arrow signifies then, it means then. So what do we want now? So if we want the inverse, we know the inverse is just changing the sign. So the inverse is going to be equal to negation of P, then negation of Q, because we're just changing the signs. But if they want the contrapositive, that's going to be equal to what? So for the contrapositive, remember, we switch the order. So we'll have Q, then P, and then we negate them. So we have negation of Q, then the negation of P. And that's just it. They asked us to state that, and we did. And now they're asking us to copy and complete the table below to show the truth. Copy and complete the table below to show the truth table for P then Q and negation of Q then negation of P. Okay, so they give us the contrapositive, and yeah. So let's go. So negation of P, we have 0, 0, 1, 1. For negation of Q, we have 0, 1, 0, 1. For P then Q, we have 1. So remember, for P then Q, this is if P then Q. So if P is true, then Q should be true, right? So for this one, we know that when it's TF, when the second one is false, when the first one is true, then that can't work. So we're just going to take 1 0 1 1. And for the last one is the negation of Q, then the negation of P. Well, that's just a contrapositive, right? So we look at negation of Q, and then we look at negation of P, and we just want to make sure that negation of Q does not have a 1 when negation of P has a 0. Okay? So if negation of Q has a 1, then when negation of P has a 0, then it's not true. So in the first one, we have 0 0. That's going to be true. In the second one, however, we have 1 0. And I know because negation of P is here, you might be inclined to use this one first, but the statement says negation of Q first. So whichever one is first, that's the one you deal with. So in this case, 1 0, that's going to be false. 0 1 is going to be true. Sorry, we're using ones. And 1 1 is going to be true. Great. And now they're saying if these two are logically equivalent. And are they? So we look at them, and yes, they are. Yes, and it says to justify your response. That means they just want you to tell them because the truth values are the same. And that's all they're asking you to do. And so this is 2015. It's going very nice. And yeah, we'll continue now with the last past paper of the video with June 2014. So let P, Q, and R be three propositions. Construct a truth table for the statement P then Q and R then Q. So look at this. They told us that we have P, Q, and R, and those are three propositions. So what have I been telling you from the start? So I've been saying that the number of rows we have is 2 to the power of n, where n is a number of propositions. So in this case, we have three propositions, right? So that means it's going to be equal to 2 to the power of 3, which is equal to 2 times 2 times 2, which is going to be the same thing as 8. So now we know we're going to have 8 rows. So we're going to have P, Q, and we're going to have R. We know that much. And we know that they're going to want us to do P then Q, so we can just write that down, P then Q. And they're going to want us to have R then Q. And then they're going to want us to do the AND for both of these. So they're going to want us to do P, then Q, and R, then Q. Why I did it this way? Because it's a lot easier. Because now we're just... I should use the laser. Now we're not worrying as much, right? Because we know that this is what they want. So instead of like just doing P, Q, and then P, and then just like trying to do all this in our head, we could instead write it all out. So first we write down the P, then Q, which should be this section right here, and then we'll write down the R then Q, which will be this section right here, because this is going to make our life easier, because then all we have to do is just do an AND gate, and it looks like a lot up here, but what we're doing is just checking if these two values are true, and that way we can just write down whatever value we get. But now, how do we actually arrange our table? So how you arrange your table is when there are 8 rows, we're going to want to do it like this. So in the first section, we're going to want to have 4 ones. We have 1, 1, 1, 1, 0, 0, 0, 0. In the second section now, we're going to do it like how we normally do, which is 1, 1, 0, 0. But we have so much extra space now that we're going to actually just have another segment of 1, 1, and 0, 0. And for the last one, you could probably guess, but we're just going to alternate 1, 0, 1, 0, 1, 0, 1, 0. Okay, now they're asking us to do P then Q. Remember, this is only false when P is true and Q is not. So we're looking at P and Q. So 1, 1, 1, 1. We know all of the... Oh, sorry. 1, 1, sorry. But when we go here, we realize that P is true and Q is not. So these two are going to be 0. And then the rest of these will just be 1 because, yeah, this section works out because P is not true. So Q could kind of be anything, really. And now we're going to the R then Q. Well, yeah. And this is 5 marks just for constructing a truth table. So that's very nice to have. So we're looking at R column right here, and we're looking at Q column. So remember again, when R is 1 and Q is 0, then it's not true. But so far we have 1, 1, 0, because right here. R is 1, Q is 0. 1, 1, 1, and then again we're going to have 0 right here, and 1. And now all we have to do over here is just use an AND gate. So when both of these statements are true, then it's going to give an output of 1. So we're going to have 1, 1, 0, 0, 1, 1, 0, 1. And that's all. But for reference, I would recommend drawing a table. Actually, my teacher would take marks off if the table wasn't closed off and done properly. But I just couldn't really do it much better right now because I'd have to like draw a very nice and fancy table. And yeah, and that's pretty much all you have to do. Truth tables is a very easy topic. I'm hoping that you guys are understanding it. If you are, then that's good. If not, then you can always rewatch the video or check your textbook or find another video that might be better suited to you. So with that said, that's pretty much the end of the video. We're looking at the notes right now. It looks kind of hectic, but you went through a lot of past papers today, just doing all these questions. If you understand how to do these, I'd say you have a pretty good chance at understanding truth tables on the exam. And yeah, good luck. Hopefully you guys do well. Hopefully you're not waiting too long to study, because pure math is definitely a test that you have to study consistently for, and hopefully this is helpful. Thank you for watching.